Hello, this is Mr. McGovern, and we're going to look at the fifth video in the Projectile Motion series, which is on components. So in the last video we looked at a ball which was moving horizontally off a cliff, and it was fairly straightforward for us to realize that the horizontal component of velocity, how fast it's moving horizontally, was 25 meters a second. At the start, its vertical velocity was 0 because it wasn't moving in the vertical direction until it started accelerating. What about when we have a problem like this? This is a question from an NCEA exam where a cricket ball's been hit and it follows a projectile trajectory, but its initial velocity, it's hard to see what its horizontal part is and what its vertical part is. I don't think its vertical part's 0 because it's moving up to start with, and its horizontal part's definitely not 0 either. So we don't know what its horizontal speed is, we don't know what its vertical speed is. And now the way we problem solve this, remember we had the table with the horizontal parts and the vertical parts, and we dealt with them separately. This one to start with, I don't know, this 20 meters a second, is that horizontal or vertical? I'm not sure. So what do we do here? Well, we have to look at it in components. And what we need to do is we need to redraw the initial velocity as a triangle. So I've redrawn it here. I felt that their 40 degrees was a bit too generous, so here's my 40 degrees on my triangle, and there's the 20 meters a second. And we say that the other sides of the triangle, the horizontal side and the vertical side, are the horizontal and vertical components of the velocity. Okay, so they are the initial vertical one, that side of the triangle, and horizontal one, the bottom side of the triangle. So if we can find those out using a bit of trig, then we have got our starting point to do any calculations with this. So for the exact same numbers here, how would I go about calculating this? Well, it's a triangle, and I like to draw on my triangle the hypotenuse, adjacent and opposite. So opposite the angle, I've got the adjacent to the angle and the hypotenuse, which is the 20 meters a second. I also like to write down SOHCAHTOA before I start, just so I know to put the right pairs of sides together with the right function, and then identify the missing values. So say I use sine, opposite over hypotenuse. My hypotenuse is 20, and my opposite is the vertical velocity, Vy. Rearrange that, I get 20 sine 40, and that gives me the initial vertical speed is 12.9 meters a second. I could do the same with cos. That's adjacent over hypotenuse. The adjacent is the Vx, which is the horizontal speeds, or horizontal velocity. Rearrange, and I get the horizontal velocity to start with is 15.3 meters a second. So this video, I've looked at a more complicated version of projectile motion. Instead of something just moving horizontally to start with, then adding in that vertical component. Here we've got a vertical component to start with, and we're not sure what that is. The way we work out what those components are, we use our triangle.